Okay, good afternoon. So this is going to be our final lesson on immunity. We're going to be looking at the idea of monoclonal antibodies, and they're a new type of drug in relation to fighting disease, mostly for trying to fight cancers, although they can be used for a few other things. So, yeah, as I said there, they're a quite experimental, fairly new drug, mostly used for fighting cancers. So we're going to have a look at how they work now. So you're hopefully aware that cancer cells are cells of the body growing out of control that don't respond to death signals. So often their antigens have changed in some way to make them not respond to death signals. So what we may want to do is we can isolate those antigens from the cancer cells. So we get a biopsy of cancer cells and the antigens are actually removed from them. Then what we do is we inject those antigens into a lab animal like a mouse. We're not actually injecting the cancer cells in, just the antigens from the cancer cells, okay? So that goes into the mouse, and then the mouse recognizes them as non-self antigens, and therefore it starts responding to them using its B plasma cells to make antibodies. So a reason it's really important that we have to inject it into a lab animal is one of the main issues of cancer is our body isn't recognizing the non-self antigens, okay? The antigens may be changed slightly, so they're not found on all cells, they're only found in our cancer cells, but they're so similar to our cells that our body cannot pick up on them. But by injecting them into a lab animal, they are sufficiently different for it to pick them up as being non-self antigens. Therefore, it responds and it produces antibodies specific to them. So, as I've got down here, the mouse responds and it produces antibodies from its B cells. And then those B cells are removed from the mouse, okay? So the mouse's B cells are removed, and in a lab, they are fused with myeloma cells. Now, myeloma cells are cancerous cells, and the fusion of the B cells and these cancerous myeloma cells makes what we call a hybridoma, so a hybrid of the B cells and the cancer cells. Now, the reason for this is it will have the properties of both cell types. So the B cells are producing antibodies that are specific to a certain antigen, whereas the cancerous cells have the properties of rapidly growing and not dividing. Rapidly growing and dividing and not dying. So when they're combined together in the lab, we get cells that produce antibodies specific to the cancer, and they're growing at a really rapid rate, making loads and loads and loads of antibodies, okay? So, as I've said there, that's what I just explained. And the antibodies we made are called monoclonal antibodies. They've all come from the same source, therefore they are all the same, all specific to the antigens found on the cancer cells. So finally, we take just those antibodies, not the cells that make them, just the antibodies, and we inject them into a patient, where theoretically they should bind to the cancer cells, and therefore make them more visible to the immune system. Functionally, sometimes this works, sometimes it doesn't. It's a pretty new technology in relation to anti-cancer drugs, but it does have a modest success rate, and the technology about it is getting better all the time. So, as I've put there, once they've attached to a cancer cell, the cancer cells then become more visible to the immune system, so things like natural killer cells can fight them. It may slow down the cancer cells' division, which is really important. And a very experimental new thing they're doing is they're trying to attach radioactive particles or chemotherapy drugs to the actual antibodies. And that means it would deliver the drug or the radiation directly to cancer cells. You're probably aware that chemotherapy and radiotherapy are two ways of treating cancer. But they both have pretty bad side effects because it's very hard to target them to only affect cancer cells. Both the treatments, chemotherapy or radiotherapy, destroy a lot of regular body cells as well, which causes some of the side effects. So the idea of attaching the radioactive particles or the chemotherapy drugs to these monoclonal antibodies is the monoclonal antibodies should only bind with the cancer cells, and therefore it should take the radiation or the drugs directly to the cancer cells. So yeah, so that's the basic idea of monoclonal antibodies. It's basically making antibodies from a cell that's a mixture of a cancerous cell, which will rapidly grow and divide, and a B plasma cell that makes antibodies specific to a human cancer cell. Thank you.